Hi everyone. Today I'm going to be going over your Friday math warm-up. And if you look in the math warm-up Google Slides that have been shared with you, your Friday warm-up has a word problem. And it says Chase spent the day baking and he used lots of flour. It says he used 2/3 of a cup to bake bread, 3 1/2 cups to bake a cake, 2 5/6 cups to bake brownies, and we want to know how much flour did Chase use in all. So to determine how much he used in all or total, we have to use addition. But I noticed something about my fractions and mixed numbers. 2/3, 3 1/2, 2 5/6. If I look at their denominators, 3, 2, 6, they're all different. And when we're adding fractions or mixed numbers, they have to have common denominators. That means their denominators have to be the same. So we're going to have to convert these fractions so they have like denominators. To do that, you can use the lowest common multiple or LCM. So what I did is I wrote the digit for each of these denominators, 3, 2, and 6, and I'm going to list multiples of those numbers until I have a multiple that is the same for each one. So we start with 3, and we can list multiples 3, 6, 9, 12. We can then list our multiples for 2, 2, 4, 6, 8. And finally, we can list multiples for 6, 6, 12, 18, 24. And I'm looking for my lowest common multiple, so the smallest number that is the same for all three. And I see that that is 6. So I want to change my fractions so that they all have a denominator of 6. So what's kind of nice about that is I don't have to change my 2 5/6. That can stay the same. So I'm actually going to erase this work that I have right there. But I know that I have to change 2/3 into sixths. And to do that, we used multiplication. So I have to think, what did I multiply 3 by to get 6? And I can actually use my multiples right here. I see I multiplied 3 by 1, 2. It's that second multiple. So I multiplied 3 times 2 to get 6. And what's important to remember with fractions, besides they have to have common denominators to add, is that whatever you do to the bottom of a fraction, to its denominator, you also have to do to the top, to that numerator. So that way you're creating those equivalent fractions, fractions that are the same size. So because I multiply my denominator by 2, I also have to multiply that numerator by 2. And 2 times 2 equals 4. So 2/3 is equal to 4/6. I'm going to do the same thing to 3 1/2. I'm going to keep my whole number 3 the same. That is fine. But I need to look and see, I multiplied 2 times 1, 2, 3 to get 6 as my new denominator. And because whatever I do to the bottom, I do to the top, I'm also going to multiply that numerator of 1 by 3. And 1 times 3 equals 3. So now I'm going to add 2 5/6 plus 3 3/6 plus 4/6 to see how much flour Chase used total. So my first thing I can do really easily is add my whole numbers. And 2 plus 3 equals 5. Next, I'm going to add my fractions. I have 5/6 plus 3/6 plus 4/6. Now, when I'm adding fractions, I'm only adding the numerators. When we're adding fractions, the denominator stays the same. So I need to keep a denominator of 6. I only add those numerators. So 5 plus 3 is 8, and 8 plus 4 is 12. So I have 12/6. Ooh, but I noticed something. My numerator is larger than my denominator. Uh-oh, that means I have an improper fraction. And I need to turn my improper fraction into a mixed number. To do that, I can look at this fraction bar like a division symbol. And I don't know if you can see, I actually wrote the dots so it would look like a division sign. So I'm going to take 12 divided by 6 to come up with a mixed number that's equal to that improper fraction. So I'm going to take 12 divided by 6, and I'm going to think, how many groups of 6 can I take away from 12? Well, I can use my skip counting. 6, 12, oh, I can take away 2 groups of 6. So I'm going to write my 2 right above there where my quotient goes, or answer to a division problem. And 2 groups of 6 is 12, so I can subtract 12, and then I would get 0 as a remainder. Now, when you use division to turn those improper fractions into mixed numbers, your quotient right here is your whole number, and then your fraction that remains, your remainder would be the numerator, and your divisor is the denominator. But looking at this, we have no remainder, so 12/6 is just equal to 2, that whole number. So that's not my final answer. If we think back, we added our original 2 whole numbers, 2 plus 3, to get 5. So I need to take 5 and add it to my 2 over here to get my final answer. And 5 plus 2 equals 7. Well, 7 what? If I look back at my word problem, remember, with word problems you need to label your answer so we know what those numbers represent. And if I look back, it says, how much flour did Chase use in all? And when he was measuring, he was using cups as his unit for capacity. So I'm going to say he used 7 cups of flour. There we go. So when we're adding those fractions and mixed numbers, sometimes there's a lot of steps that we have to take. So make sure you're being careful with showing your work, being very neat with your work too, because if you get kind of messy with your work, it's really easy to misread something or make an error. Making sure you're going back and seeing that you've taken all the steps you needed. If you have questions about how to add fractions or mixed numbers when they have different digits in the denominator, or if you have questions about changing those improper fractions to mixed numbers, please email me, let me know, or your math teacher. You can send us emails, or you can also leave comments in your math warm-up Google documents. All right, hope you guys are doing well. Bye.